the graph of a polynomial function is considered to be continuous. So it is continuous. Which means, I wrote that weird. Which means that the graph has no breaks, holes, comma, or gaps. So to keep it simple, in calculus 1, they'll go more into the definition of continuity. But for now, we're just going to keep it simple. It is continuous if the graph has, if you have you graph the function of a polynomial, there is no holes, no gaps, it's all connected, smooth, it's just straight up. Okay. Does that make sense?
Yes.
Yes.
Yeah, let me see if I can find a nice picture for the next part.
Oh, sorry. I also had another question.
Mhm.
The I think the graphs you gave us to download,
Yes.
we can use them on the test, right?
Yeah, those won't count towards your formula sheet.
But that's the thing. How would we use it on the test if we're using Respondus?
Well, you'll have to upload all your, so you're allowed 1-page formula sheets for your exam.
But we cannot go outside of Respondus. Like we
Yeah,
cannot look at.
you would have to print them out or write them down.
That's the thing. My Mac doesn't have isn't able to print it out. It would need a Bluetooth printer or something that Bluetooth, because it has no printing USB for anything.
You can either just write them down, draw them out, or you can print them at what's it called, Kinko's or that FedEx place, UPS store. You can just email it to them, they'll print it for you if you want to go that route. You can print at the school. I believe there's fees depending which school you go to.
Okay.
If you're on campus often, I can print them for you. Just let me know. Give me a heads up.
Yeah, I'm there every day Monday through Thursday.
Yeah, maybe we can do that. Just we can talk about it another time. We'll meet up at some point.
Okay.
If you've got a library card, you can use the San Antonio Public Library. They'll let you print stuff for free. There's just a page limit.
Well, that's the thing. My laptop does not have any USB ports for anything to print. It just has two. It just has two little charging plugs.
My library, I was able to print it off my phone. I didn't have to plug anything into it.
Okay, I don't know how that would work.
You can probably just email it to yourself and download it on a public computer or put it on a USB drive.
Yeah, I think I'll probably am getting it from you.
Yeah, let me know. I'll do that for you. No big deal.
Thank you.
Okay. So leading coefficient test. This tells us that the graph rises or falls depending on whether the leading terms are positive or negative. Now we'll graph a couple just to see it. Excuse me. So let me do a little sub thing here. 2A. You'll have left behavior. If it's negative. You'll have right behavior. If positive. Okay. So let's find a graph real quick. Oh. So it says if it is positive, we have right behavior. So let's put like a big, I don't know, let's put a 3 in front. All right, let's compare that to another function. It is -3. This is what they mean by left behavior and right behavior. 1 second. Give me a moment. Okay, so if it's positive, it's gonna fall on the left and rise on the right. Okay, so if it is negative, it's gonna do the opposite. So they're talking about the leading coefficient. Hey guys, do you guys know, or are you familiar with what leading coefficient means?
No, I guess the the one that has the highest exponent.
Or was like the first coefficient?
Yeah, it's the coefficient of the one that has the highest exponent.
Okay.
And if it's in order, then yeah, it would be the first one. So let's say I had some random example. Right. A is the leading coefficient here. So we're looking at the sign of this guy for number 2. Let me switch back. So if you have some A, if A is the leading coefficient, so if A is negative, right? A less than 0, A greater than 0, you have different types of behavior.
Oh, I have a question that I saw for the last one. We were seeing that for the A that sometimes it has like when the case of the first term, it has like sometimes it has a 3 like but next to the A, but it's like instead of being the exponent, it's like down. I don't know.
Oh, like a subscript?
Yeah, like sometimes like yeah, instead of the exponent, it's like down next to the A.
What was this, a homework problem or what was this?
Like the base. I don't know, like base 3.
Yeah, I mean, if it's a subscript, usually that's saved for bases or in like logarithms or different systems. But I don't think that shouldn't have come up yet. I don't think. But yeah, it's usually reserved for base. Okay. Here's another definition or theory stuff here. A polynomial has a polynomial of degree n. I think here on campus in the library you can print stuff too. I just don't know how it works. I've never done it. Polynomial of degree n has at most n real zeros. And at most n minus 1 turns. Okay. I think that's all we're gonna need here. If not, we'll write stuff as we go. Alrighty. Let's look at number 9 here. Sorry. Okay. So looking at this function here, what type of graph would this be? Right, you see it's the highest degree is 2. So whenever they mention degree, they're talking about the highest power on any of your variables. So if the
Would it be
highest
B?
B,
See, because reflected parabola.
yeah, it's gonna is the negative mean
Oh,
is gonna be pointing down.
Okay, I see that.
And A and B, you see Y and D don't make sense?
Yeah, it was between A. It was between B and C for me.
Yeah,
And
because
then C, I forgot about the reflection.
these are higher degree. So see how it has multiple terms?
Yeah, and then I see it where it, yeah, I see. It was a negative. I didn't see a reflective.
So if you have multiple terms, that means it has to have a higher degree. So look at what we wrote down for number 3. We said a polynomial of degree n. So our degree is 2. So we should only have 2 minus 1 terms, meaning we should only have 1 term. But look at this guy. Right, it goes turns 1, 2, 3. You see that? How it turns multiple times, 3 times.
So would that be to the n3
It would be
or to
one
the
more
bottom
than 3.
more than 3? Okay.
So because it's n minus 1 turns, right? So that means degree has to be 4. 4 minus 1 is 3 because there's 3 turns. You see what I mean?
Yeah.
Well, this guy only has 1 turn. So that would mean 2 minus 1 or n minus 1 turns. So degree is 2. So it has to be one of these. Reflection pretty much guarantees it. So we choose this guy. Okay. Does that make sense? The reasoning? I mean, I know it's obvious on this one, but I want you to think about all those ideas. Right. Let's look at this guy. Look at it. There's a 4. Okay. So it should have, so this has degree 4. Does everyone agree with that? Highest degree here, highest power is 4, right?
Yes.
So how many turns would this guy have?
3.
Yeah, it should be 4 minus, so the highest degree minus 1 will give you the total number of terms. So ours is 4 minus 1, so it has to be 3. This has 1 term, so that's not it. This is the same crap, so these are wrong right away. This has 1, 2 terms. So this is a 3rd degree function based on that theory that we wrote down, number 3. This is like the one we just talked about. So 1, 2, 3. So the degree has to be 4.
So do we always subtract by 1?
Yeah, you will always have n minus 1 terms.
Okay.
Where n is the degree of your polynomial. So if I have a 4, it means I have 3 terms. If I have a 2, that means I have 1 term, etc. Does that make sense?
Yeah.
Yeah, so the 3 shows as 2 terms that are 3x because it's squared,
Oh, the
and
last
that's for the that one right there.
well, this, so you look at the highest
Yeah.
power. So first you got to decide what is the degree of this function, right? So the
Right.
highest power is 4. So the degree of this f of x is 4.
Okay.
So there's 1, and that will tell you how many terms.
And then I also see that the 3x squared, between those two curves on the top, it shows that they go 3 points to the right and to the left. 1, 2, and 3.
For which one?
Number 1, the one that was right, the correct one, the first one.
Oh, this guy.
Yeah.
Oh, you're talking about the zeros?
Yes.
Yeah, we have a few zeros here. Let's see. Yeah, it looks like that's 1, 2, 3, 4, 5. So that'd be 1, 2. Looks like between 2 and 3, right? This is 1, 2, 3, 4, 5. That's somewhere between 2 and 3 as well. So it's going to be a fraction for this guy. It's not a pretty one, so we would have to figure that out. But they haven't asked for that yet, but we will be doing that soon.
Okay.
But for now, you need to use the stuff I wrote down and kind of figure out what the function, what the degree is going to be, what it looks like, what it's doing, right? We should know that if it's an even function, it'll have a kind of a parabolic shape like this, something like this. If it's odd, it'll be more like this. Not exactly, but similar. So since the 4th power, see, it's kind of like a parabola. Negative means facing down. Okay.
I have a question.
Mhm.
What happens if the exponent is negative?
It would be a different kind of function. I believe all of them here will be positive. Because negative would be different. It would be a rational function. I think that's later in the chapter. That would be like 1 over x or 1 over x squared. Those would be negative exponents. So I believe that's later, not yet. Those are good questions though. Okay, so here it's a 4th, so we should have 3 terms, right? So just by looking at which of these has 3 terms.
Is it C?
It's kind of hard to see on this graph, right? It is C, but it's like 1, 2, and then it turns back up again. So it like turns down and then up. So we would have to zoom in to look at it. Let's see what decimal says.
So the only thing we have to do is just like subtract it and see if it combines.
Yeah, I think it was at the first one. So I think it was, I don't know if we already did it, if we already saw it.
What's up?
Yeah, but I think I know where it's at. The points are.
Oh, you found it?
Yeah, I think I see them on the, yeah. Well, there it shows right there.
Yeah, well, this one I think might be a different one, this guy here. So if you zoom in, you can see how it turns down and up and then turns again. So right
So
here.
the
they're
points
like,
at the points at the highest point, the lowest point, and then the next highest point.
Yeah, so at these zeros, there's some terms. Also, number one that we wrote down, we said. Where was it? No, that was number one. Oh yeah, on number three, we said it has n real zeros at most. So here you only see 2 zeros, right? So we didn't, even though it was a fourth power, we only had 2. So you could have 4, but you will never have more than the degree. So you're always guaranteed should say it will never it'll be guaranteed that it will never be more than the degree. So if it's degree 4, you'll have at most 4 zeros. Maybe you'll have 1, 2, or 3, maybe 4. You won't have 5 zeros if it's a fourth power function. Does that make sense?
Yes.
Although it's possible to have like no zeros, right? If I shift it upward, I don't have any zeros. So you could have 0 zeros. You're not guaranteed. The only thing you're guaranteed is you can pass n, where n is the degree. Okay. 5 should have degree 5, right? This is a 3, it's 1, 5. 5 is the biggest. So the most number of turns you can see, right? 1, 2, 3, 4. 4 is 1 less than degree. This has a 1 turn, 1 turn, 2 turns. Obviously, it's this guy. So the turns, then the zeros can help you out. Like if they're very similar, then you're gonna have to start looking at the left behavior and right behavior. Let's say that you had 4 options that all look like A, right? So then you look at the turns, look at the number of zeros, and then look at the behavior and see what matches up with what you're given. You see what they're trying to get you to do. So number 2, we wrote down that if the leading coefficient, the number on the highest power, is positive, then we have right behavior, right? So if we were to graph it, we would see right away. F of x equals to 11 cubed plus 7x. Oops, what was it again? 11x cubed plus 7x. This is pretty weird. I need to change the x values would be good. Slightly better. I'll do -2 to 2, I guess. Just trying to make it prettier because okay, now it looks like a cubic function, right? So as you can see, it's falling to the left, rising to the right. That's what we said was right behavior. Rises to the right. Okay. So they're just kind of quizzing you here. You're asking, okay, well, if figure out first what is this, and then you decide, okay, it's right behavior, and then right that means right rises to the right, falls to the left. Okay. So this is the same thing. So I would probably graph them to be safe. Yeah, I would say on number 13, just I would just graph them and look at the behavior. I think that's the easiest thing you could do. but using the definition we wrote down, it will always rise to the right. Yeah. But depending on what type of function, it may not fall on the left. Okay, let's check this out. This has a positive, but a 4, I guess, who cares? 4 is positive, so it has right-hand behavior. So it's rising to the right. But notice on the left, it's not falling, it's also rising. So it depends on the function. Check this guy out. 4x cubed. So that also rises to the right, but on the left, it's falling. Okay. And then fourth function, as we said, is kind of a it's also parabolic, so it's similar. So it just depends. So you don't mess up the choices here. I would graph it just to check yourself. But if the leading coefficient is negative, it will fall on the right. Okay. Anyway, any question on that? Does that make sense? Now, here's a new idea, number 17. Here that we're actually going to find the zeros and they're going to ask about multiplicity. So if you watch the videos or read the book, this is referring to the power on your factor. Okay. So you have to factor it first, and then you look at the powers on those factors. And depending,
Difference of squares.
yeah, this would be different scores for sure. So when you factor this guy, you're gonna look at the factors and check what powers are on there. If it is odd, then they will show you. They will cross. See how the 0 is right here. So if the 0 is right there, 3 and -3 once we solve for it, it's gonna cross it because it is an odd multiplicity. So I'm going to show you in a second. But if it is an even multiplicity, it's going to do this. It's going to bounce off 0. See how it doesn't cross? So that's because of the multiplicity type. Okay, so let's go ahead and do this by hand. Okay. First step is find all the real zeros. So at most, I could have 2 zeros here, right? Because it is a degree 2. So the most you should see here is 2 zeros. Maybe none, I don't know. So in order to find them, you factor this guy. Let's set it to 0. So that means that x is equal to -3 and x is equal to 3. Okay, so that part is stuff we've done many times, or you have. Part B, though, is the new stuff. It says determine the multiplicity of the zeros. So we have 2 zeros, right? You agree? -3 and a 3. So when you factor the function, notice how this is a single power, right? The number 1 is odd. So that means even. I'm sorry, odd. Odd multiplicity. Because of these numbers. So if this was like a square, then it would be even multiplicity. That makes sense?
So does that change the graph?
It has effects on the graph. Okay, so what you would answer is, okay, the 0 for multiplicity for this 0, x equal to -3 is even. Multiplicity for this guy is even. Does that make sense?
Yeah.
That's what it is. So the smaller x value would be the more negative, larger would be the positive. And obviously, as we wrote down the notes earlier, the number of turns, right? Maximum possible turning points of the graph would be 2 minus 1, the degree is 2, so 1. So this question is kind of bringing all the ideas together. Any questions on number 17?
So your answer said even, but on your problem showing odd.
I don't know why I keep writing that. I wrote odd over here. But yeah, thank you. It's supposed to be odd. The number 1 is odd.
Okay.
There we go. So if this was an even number, then multiplicity would be even, but these are odd. Any other questions on 17? Okay, let's go to another question. Let me check the book really quick. I don't know if we're supposed to use a certain technique yet. One. Okay, so let's run the top here. So given this function, Part A says find the zeros. In order to do so, you got to factor. Factor x cubed from both. I guess it's once you have two factors, you can set each part to 0 because of the zero factor property. And then solve for your x's. So here are the zeros they wanted for part A. Part B will ask us about multiplicity. So if we look at these factors here, see how this is a 1 and this is a 3, right? So x equals 0 has an odd multiplicity. X equal to, we solved this and got a 4/3. So 4/3 has an odd multiplicity. Does everyone see why it's odd?
Because they're prime numbers.
I have a question about 0. Why is 0 an odd multiplicity and not an even?
Because it all depends on the power. So the power on the 0 for 0 is 3.
Okay, so if that was a 2, it would be an even.
Right.
Okay.
Multiplicity is referring to the powers.
Okay.
So the factor in question, because those factors are creating the zeros, right?
Yeah, got it.
Alrighty. So let me just show you real quick. Excuse me. So as you do these, you're gonna have to use different factoring techniques. Like this one has 4 terms. So you should try factor by grouping. Okay. Over here, just factor 3x out of all of them, and then you'll end up with a quadratic, which will require a quadratic formula. So as you can see, they're all going to be different. You see this one's already factored for you. So number 20 will factor similar to 19. See how it's already done? So you just have to do quadratic formula on this part to get the other 2 zeros. So the 1 and the 7/3 is coming from this factor. The 0 obviously is the t squared. So keep in mind, you'll have to do factoring techniques. You can graph to verify your stuff, no problem, but of course on exams you have to show your work, okay? Let's move on to something different. Turning points, we've talked about that already. Okay. So find a polynomial, do number 24 together. Find, I switch back here. Find a polynomial. Okay, so there's another definition or theorem, I should say, that says, I guess maybe put it in my own words here. So if x equal to a is a zero of a polynomial, f of x, then x minus a is a factor of f of x. So I'm going to use this idea to figure this out. So since forgot to write zeros, 0, -3, -7 are zeros. Okay. So the idea is, if they are zeros, then that means x minus the 0 is a factor. X minus this guy. If -3 is a 0, then x minus a -3 is a factor. -7, x minus a -7 is a factor. So simplify this. This would be your polynomial. Multiply it all out and you'll have the function, right? Foil this out, you'll get x times x, x times 7, 3 times x, 3 times 7. So add that up, that'll be x cubed plus 10x squared plus 21x. Anyway, this steps or whatever. What matters here is, given zeros, the theorem tells us that they are also factors. Because you know how usually we go the other way around, right? Given factors, we found the zeros. So we should be able to go from here back to there, right? Does that make sense?
I guess, yeah.
So whatever zero they got, all you gotta do is put x minus that zero. X minus that guy, x minus -3, x minus -7. Double minus gives us a +7. Double minus here gives me a +3. Here is the answer. This is the function already done. The rest is just multiplying stuff out, but this is f of x. That's where this comes from. Maybe shift over here. You see? I found a polynomial that has these zeros. So if I were to graph this one that I just made, it's going to cross at these points. Now, do you see the multiplicity on each of those? Is 1, right? 1, 1, 1. So that means that the zeros, they would cross at these locations. Is that clear?
Yes, sir.
Let's graph it in case this makes no sense. There's a lot of theory in the background. Like the work itself will be whatever, but you need to understand the concept. Okay. So here's my graph. Notice that it crossed at -7, crossed at -3, crossed at 0. If they were even multiplicities, it would bounce off of it. It would not cross the x-axis. So in the book, that's what they mean by cross and bounce. It depends on the multiplicity. Even is bounce, odd is cross. So like if I made another one, force purposely force an even multiplicity, right? Notice how this one has an odd multiplicity. Right? So it crossed it. And 2, the 0, 2 crossed it. The 0, -3 bounced. That is determined by multiplicity. Is there any questions on that idea? That's pretty much it for that section. It's just gonna keep hammering those ideas like, all right, does it bounce, does it cross, what's the factors, what are the zeros, what is the multiplicity? So that'll be the same types of questions in different ways. Okay. All right, let me check with schedule. The schedule, see how if we're ahead or not. We're at a good spot. So we just did 3.2. Yeah, so we're gonna do 3.3 and maybe 3.4. Let's take a 10-minute break, and then we'll start again. Okay. So to find zeros, you need to factor. In order to factor anything greater than 2, the degree 2, you're gonna need synthetic division. Especially if you can't do like GCF or grouping, that type of stuff, you're gonna want to do synthetic. Synthetic will always work. It just can be a little difficult. Now, quadratics you've done many different ways, so that had all kinds of different ways to do or techniques to find zeros or factor. So now there's just a new one for things that are greater than 2. Okay. All right. So it is an algorithm. Let me find. Second, let me look at the book first before we start. Section tends to have a lot of theories, this chapter. So they have to give you 1 0 in order to start the actual factorization, the synthetic division. Otherwise, you'll need to find all the possible zeros. There's like a way to create a list of possible zeros. That doesn't look like they do the possible type here. I think they're gonna start basic examples. Okay. Yeah, so we show you the assignment. So the idea is if you have a function, this right here is the division algorithm, the remainder theorem. So the divisor times the quotient plus the remainder is equal to the function. So you can divide the divisor out, then you'll have the quotient plus your remainder over the divisor, right? So when you did long division back in the day with numbers, you would write the answer on the top, right? Like for example, you get a this. Let's say you're doing like 2 and 2, I don't know, 11 or something, right? This is my divisor. You would go into this 5 times, right? 5 times 2, and you would subtract. You all remember this, right? So Q is the 5. Okay. R, remainder, is equal to, oh, they use lowercase r's. We use lowercase. Lowercase r is equal to 1 over your divisor. So that's how you would get the decimal. So on your calculator, that's what it does when you divide something, right? Gives you the number 5.5. Because you add, right? You add the remainder. So the quotient plus the remainder is the function or the number divided. Does all of that seems familiar to you? Do you remember?
Yeah.
But anyway, so that's all back in the day, right? So just don't let all these weird symbols bother you. It's just divisor, quotient, remainder. They're just writing them in terms of functions instead of numbers. That's the only difference. So here they're testing you to see, okay, well, what is D? What is Q, right? So the theory and the videos will help you understand the background. I'm going to show you how to do synthetic division, right? Let's see here. Here they want us to use long division, not synthetic division. Long division is a real pain, so let's go and do it. Sorry, sure is noisy. Let's do number 8. First, let's do basic numbers. So let's say 5 divided into 595. Okay, so the algorithm, right? The pattern means you use this number, you divide into the first. If it goes in, you put a number, right? The number of times it goes in. And then you do 1 times 5 and you put that here.
Sir, are you sharing the screen, or are you gonna be sharing like your notebook?
Sorry about that. Yeah, you're right. Didn't shift over. There it goes. Can you see it?
Yes.
So here's the algorithm, right? 5 into 595. 5 goes into 5 1 time. 1 times 5 is -5. I know this might seem silly, but you need to remember this pattern, right? Exactly the way I did it, because we're going to do this with polynomials. So 5 times 1, 5, and then you switch the sign. You always switch the sign. And then you subtract, right? 5 minus 5 is 0, and then you bring this guy down, and the pattern just keeps going. Start over. 5 into 9, 1 time was 5. Switch the sign. Subtract. Bring down the 5. 5 into 45. Multiply. Switch the sign. Remainder 0. So this is saying, right? 5 divided by 5 is equal to 119 plus 0 over 5. If there was a remainder, it would have a number here. But honestly, in this case, it's just this, right? That's what that remainder theorem was telling us at the beginning, that you can rewrite a quotient as a, sorry, we can rewrite something being divided as a quotient plus remainder over divisor. Okay. Is there any questions on the basic pattern. Does everyone remember?
So I guess synthetic is for the like linear functions.
Synthetic will be later. Synthetic is better, but we
Yeah.
got long division first. This is long division right here. Use long division to verify y1 equals y2. Y1 is equal to x cubed minus 2x squared plus 4x minus 1 over this divisor. Is that indeed equal to y2, the quotient plus remainder form? So this is the quotient plus remainder over divisor. This is the original function over divisor. So the way you divide this is like this. You make sure that you're not missing any degrees. You have to have every single one. So 3, 2, 1, 0. Every single power. Okay. So since we have all of them, we're good. You're only going to use this first part as your divisor. Over here, I'm going to do my scratch work, so it's not confusing. So x goes into x cubed how many times? Right, just like we did before. 5 goes into 5, 95. You do the first term. X goes into that first term. X squared times. See what I mean? Now the next step, right? We said, well, once you get the 1, you do 1 times 5. So you're going to do x squared times these two. That would be x cubed plus 2x squared. But then you have to subtract, just like we did that 5, right? You do minus. So subtract the entire thing. So you agree that when you subtract them with parentheses, that they swap signs, right? So x cubed minus x cubed, 0. -2 minus 2 is a -4x squared. You guys still with me? Anyone? Anyone having issues with this? Because it is very weird. You subtract, that's basically what we did here, right? 9 minus 5 is 4. So now we're there. So now you do it again. X goes into x squared. How many times? -4x squared.
Guess it would be -4x.
Yeah.
X.
Mm-hmm.
How how'd you get the 4x from a minus 2x and then a plus 2x?
Because you have to subtract the terms, right?
Okay, yeah, I just saw that. Never mind.
Yeah, so
Okay.
don't forget, that's where the mistakes always happen. So swap the signs. So if you have like 3 terms or 2 terms, swap all of them. So
Okay.
opposite signs. So right here, that was 4x, and now we've got to multiply. So 4 times x. 4 times 2. Minus. So these are both minus, so -4 minus 4. X squared, right? And then -8 plus 4, -4x. Hold on a second. I think I made a mistake. -2 plus 4 minus 1. X plus 2. I got these two are correct. 4x times that is this. Oh, this should be minus. There we go. See, the minuses are what's going to get you. So minus is a plus. So -4 plus 4 is 0. So that's gone. 4 minus 8. That was this guy here. Okay. So far, you guys okay? So now we go again, right? -4x divided by x. So this one divided by x. -4. -4 times these two will be minus -4x minus 8. So that'll be plus 8. So this will be minus, that'll be 0. Minus will be plus 8. I feel like there's an error again. Dang it. -4.
What happened to the -1? You didn't bring it down?
Yeah, that's what I'm looking at right now. Because it looks like the answer is supposed to be 12 for this part. So if I bring down the negative, -1 minus, I mean, that would still be wrong, it looks like. Because they have a 12 here. I did the division. This was good. This is a minus, that's a 4. One again. -4 times both of these, that'll be negative. Now, oh, okay, here it is. No. This should be -8. Because -4 times 2, -8. Negative would be plus, so this would be 12. There it is. Okay. 2 mistakes. I'm sorry. It's very tedious. So this was 0. This was plus 12x. So now I get my plus 12. Okay. And then bring down the -1. 12 times x would be negative parentheses 12x. 12 times 24 would be 12 times 2 is 24. That would be minus, so that would be 0 and minus 25. There we go. So now we cannot divide any further because x does not go into 25. So the answer will be this plus the remainder over the divisor. Okay, does that make sense? So this becomes this. Are there any questions on this problem?
Can you do another one?
Yeah, I think we should. Okay. Let's do number 9. Here, they're not asking us to verify anything. Okay, so sure. Let's do this guy. Number 9. You guys cool on that page before I turn the page?
Yes.
All right. And don't feel bad if you don't like long division. I don't think anybody does. But use long division on this guy. Okay. So this divided by that. That means that this guy goes outside, right? Okay. I'll do my scratch work over here. So x goes into the 4th. X cubed times. X cubed times x plus 7 is x4 plus 7x cubed. So that would be x4. Oh, well, before you start, you should always check. Do we have every single power? 4, 3, 2, 1, 0. Yeah, we're good. If one is missing, let's say there was no cubic, but there was a 4 and a 2, then you have to fill in the blank to the 0. So just put like 0x cubed. Does that make sense? So if there's a missing one, just put a 0 times whatever's missing. So that goes right here, subtract. This is 0, 10 minus 7, that's 3. Start over. 3x cubed divided by x. It's 3x squared. So plus 3x squared. Now multiply 3x squared times x plus 7. That'll be 3x cubed plus 7x squared. So I'm going to bring that down. Plus 21x squared minus this garbage. So 3 minus 3 is 0. 21 minus 7, that is a 14, right? Start again. 14x squared divided by x. That'll be 14x. You guys still with me to this point? Any step that I may have lost you at?
Why didn't you do 7 times 3x square?
Let's see, did I make a mistake again? 3 times x, 3 times, yeah, that should be 21, right?
Yes.
Yeah. Interesting.
Yeah, I was gonna say that because on the right side on your work, you put I think it was a 3x square and then the x plus 7. And you put 7x square instead of 21.
Yeah. Yeah, please let me know before we get too far, because
Isn't that negative 21?
will be. You mean like in here or at the end?
Yeah, on the inside.
Inside. This is a positive 3. Oh, x plus 7, right? It should be positive. But why do you see negative? Maybe I'm missing it.
Or, oh, I'm sorry, maybe I'm saying that backwards because it flips to negative after you change the sign.
Yeah, it's gonna flip to negative after. But right
Okay,
now,
sorry, that's what I meant.
okay. Yeah, then we agree then. We both agree. So this will be 0 minus minus. This will be 0 as well. Interesting. Okay. Now we bring down the x. X goes into that one time, right? But -1 will be the end. Yeah, that's why I do it on the side, because it's so easy to make a mistake on this type of problem. Oh, cool. Got 0 again. That's nice. So this guy has no remainder. So the answer when you divide them will be the quotient, and that's it. Any questions about any of the steps? We don't have any more time for problems, sadly.
On the top, that's a equals one, positive one.
Oh, this, no, that's just a bunch of stray marks.
I have another question.
Mhm.
Is that a -1 or is that a -x?
-1 up here.
For the last answer.
Here. Or this.
Yeah, that one right there.
Yeah, it's the same as the top. This is the quotient. X cubed plus 3x squared minus 1. So this whole thing, once you divide it, you get this. That's what we got.